Hi,
Hello.
Bethany, how you doing?
Good, how are you?
I'm good, thanks. Yeah, absolutely. So, our audience have been busy over that, and the first question is that from your talk, you use a lot of archive resources, and do you get requirements from clients at all that their 3D models and apps will be archivable digital tech as it ages quickly?
It does, and that's a big problem, especially with 3D modeling. The 3D models will become obsolete very quickly. Usually, the things that I create for my clients, they end up being in video or game format or apps or things like that. So they're not actually dealing with the 3D model that often. So we don't have to worry too much about the model becoming obsolete. But that is something that needs to be looked into in the heritage sector as far as maintaining these models that are being built and quickly becoming unusable. So yeah, it's a good question.
Definitely. The idea of like future proofing, I
Yeah,
think.
exactly. It's a big one, and it's something that I think we need a lot more research into right now. Yeah.
Definitely. Oh, I agree. I do have another one for you, Bethany. So, oh, yep, this is the one. So it's an area that we do take for granted in many ways. But from a high level stance, what advice do you have, and what resources do you recommend for the converging of technologies as we move forward?
Well, so one thing, kind of tying on to what we were just talking about, a lot of tech is used in archaeology and heritage, but it's not built for that. It's not purpose built, and so that means that heritage is often having to adapt what they're doing based on the tech that's available. So I think in the future, I hope that we will be able to have people who are developing this tech specifically for the heritage sectors so that they can be used for the purpose that they're using it for. And yeah, so I think that's kind of where we're moving towards.
Yeah, more focused technology on this specific area.
Yeah,
Yeah,
exactly.
that would be really helpful. Absolutely.
Mhm.
I'm also going to invite up Cassandra to the stage now, as we do have a question for her. Thank you. Hi, Cassandra. How are you doing?
Hello.
Thank you. I was just wondering, would you be able to comment on the key distribution rate that you can achieve using your source, which we assume is using a decoy state protocol and weak coherent source?
Yeah, so a bit of background for it sounds like you know what you know QKD, but decoy state protocol basically you have different intensities that you can send at. So you have your intensity, that's your actual state that you're going to use to develop your key, and then you have either one or two decoy states, which are lower intensity, or actually a vacuum state, which is effectively zero intensity. That are used to basically help with that safety mechanism. So detecting that eavesdropper in there. I had it in my little diagrams first, but
Like a little bug in the
it
middle.
took too long. Yeah, it took too long. I had to take things out of there
Oh,
to explain parts of it because there's a lot that can go into basically securing it. So we're using the BB84 protocol, which is a decoy state protocol, and we are using a weak coherent laser source. So there's two types of QKD. There's entangled photons, and there's WCP, which is weak coherent laser pulse. And so it's basically being able to send out photons very quickly. I can't comment on the key distribution rate if it gives a bit too much on the background, but
okay.
we are using decoy state protocol. So to decoy state protocol where we have the vacuum state as your second one, and a weak coherent source. So
Wow, I think you're going to
sorry.
have to do a tutorial for me to understand all of this. That is absolutely amazing. Oh, okay, Cassandra, I've got another one for you here. Are there any other companies in the UK working in this field?
So there's a lot working in different areas of
Mhm,
quantum, basically the quantum tech field. So for quantum key distribution, there's my company, and we partner with quite a lot of different universities that are working on this. Universities of Bristol are very heavily involved in QKD. So is University of Strathclyde. There's also REL Space. That was that mission. It's a joint UK-Singapore mission. So REL Space is developing with Singapore a mission to do it, and they're looking, I believe, at 2024 as their launch date. So that's another company working on it. But there's actually quite a few companies working in other enabling portions, like where I was talking about we have to decide randomly which photon gets sent. that's using a quantum random number generator. So we need that on board. And there's actually probably half a dozen companies in the UK building different quantum random number generators. So we're working with quite a few of them as part of a different project that I'm leading called PRISMS with NPL, the National Physical Laboratory in the UK, to basically space grade some of those. So yeah, there's quite a large quantum community here. I mean, even the UK has funded quite a few quantum hubs. So University of York has a quantum communications hub, which obviously QKD is a portion of. So yeah, sorry, I hope that answered your question.
Yeah, I'm just sort of getting in the lingo of all the different acronyms for the different projects.
Sorry, there's a lot.
Well, no, I absolutely love it. I'm so excited to delve into it. More with you later, hopefully. So we've got a question from Ellie, one of our team, actually. What is the biggest barrier that AR? Oh, this is for Beth. What is the biggest barrier that AR and VR has had to overcome for large-scale adoptions, and how can that be overcome? Because I know earlier you talked about some local heritage sites and stuff, but how can we scale up quickly?
Yeah, it's tricky. The best way would to be get some of these projects going with groups like English Heritage, who have sites all over the world or all over the country. But we've found in the past that they are not as sold on these advanced technologies as far as how they would work well for their sites, but also how their clients would take to them. So I think getting people interested in using the technology, making it as easy as possible for their clients to use, and then proving the use of the technology and how it's getting people engaged in the sites, and that it's not just tech for tech's sake, but that there is purpose to it and it does help them engage with the site.
I really like that answer, because it's sort of just, yeah, considering the individual needs and making it bespoke rather than sort of a blanket, let's just scale up massively. Let's actually think client by client. Oh no, I really like that. Thanks, Bethany. Back to you, Cassandra. So what is the ideal medium or channel for quantum communication?
Well, I guess that depends on what you're referring to. So like if you're referring to wavelengths, that's going to depend on what kind of space you're going through. Basically, atmospheric losses are different for different wavelengths. So you really want to have basically, a wavelength that doesn't attenuate as much in the atmosphere. If you're talking about fiber versus free space versus space, it's going to depend on your application. So if fiber-based QKD is really good for like local networks because of that distance limitation and the fact that you have to lay fiber. So it's infrastructure heavy wherever you're going, but it is good for, I guess like citywide for smaller areas, free space for increasing that by a bit, and space for having very long distance transmissions. Now, obviously space has some downsides as well. You still have line of sight, which means that if there's cloud cover, when you're trying to send down to a receiver, you're going to get blocked. So basically all those types have a role to play. So there's no really ideal. There might be just ideal for your particular application.
Okay, so again, application dependent. I guess it's so interesting at this point, like people's sort of perceptions of long distance space, because I'm just thinking, oh yeah, please to Scotland. But of course, we're thinking on a much larger scale here. So thank you so much. Oh, another one for you. Is existing infrastructure capable of handling quantum processing rate?
So it's interesting. So how we actually receive it, it's these very specific detectors that are good at, basically detecting very, very quickly. We have, high rates of the quantum transmission. So everything is able to do that. We've shown that with our partners. We have basically our engineering model payload so far that we've been able to show, small distance on terrestrial QKD, and they've shown QKD in other places. Like there are places that have limited fiber-based QKD. So the answer is yes, we can handle it.
Oh, thank you very much. That's very helpful. I also have another one, Cassandra. Sorry, they're all rolling in at the moment. It's absolutely fantastic.
It's okay.
Actually, this ties in with something that you said halfway through that really got me thinking. You said something about the need for considering data security over the course of 10 years. You know, like, so we're here today, and then in 10 years' time, how is data security going to be managed? And I think this question really taps into that. So, what are the general use cases of quantum in the future, and what are the implications on security if people do have the power to decrypt encryptions?
Right. So probably start with that second one first. Obviously, that's why we're looking towards it. So they call it basically like post-quantum is the world. Cybersecurity is what we're looking at. It's you know, a field that has like quite a few different solutions to it, all for maybe slightly different applications. So I mean, that's obviously an issue where there's some data, you know, a message you send, probably you're not going to care as much if that gets decrypted in 10 years. Government's messages, they're probably going to care quite a bit more. Any sort of industry that's, you know, they are going to have things that they want to keep secure for much longer than the 10 years until we get quantum computing online. So that's something that's, you know, it depends on who you are and what you've invested in the data that you're trying to keep secure. But it's obviously it's a game changer in terms of how we do encryption, and what we need to look at for securing our data, because decrypting, you know, the RSA protocol is coming in the near term, and anything that you send now can be saved for later to be decrypted. So it's one of those implications you have to do now. For general use cases of quantum, I mean, it's a very broad, there's a lot of, like, I'm showing just QKD, and I spoke a bit about quantum computing, but, you know, there's a lot of there's quantum sensors, quantum clocks, there's a lot of uses for it. I mean, quantum computing, while it's a threat to cybersecurity, to encryption methods and securing your data, it also has the, really the potential to change a lot in terms of, basically in science, in basically analyzing data. There's a lot of good that quantum computing is going to be doing, which is why we're going for it. So the answer is really broad there. Sorry.
No, I absolutely love it, and I think that's great. And if you're happy to, you might have to answer some questions on Twitter that come through later on.
No problem.
Super interested. Bethany, this one's from me. What's next for Experience Heritage?
So we're really pushing forward with our augmented reality offering right now, yeah, I think we want to get into game development as well and kind of tie all those things together, because I think a lot of these things can all come together into one app, as I was mentioning with that last case study. So yeah, kind of moving forward with those kind of offerings.
Absolutely. And do you think you'll want to remain sort of in the Yorkshire region, or are we going to push further north as well?
Yeah, I'm hoping all over the UK eventually. So yeah, just trying to get the word out about our services.
Absolutely. And just as you mentioned gaming just then, we've had a question come in. Has the gaming industry helped in any way in the development of 3D rendering technology?
Let's see. Game industry helped in any way in developing. Yeah, I mean,
I guess there's always new platforms being brought out, and
yeah, I mean, it's a really interesting time to be in gaming right now. It seems like, you know, anyone can do it now. Unity is pretty easy to get into. So yeah, and I think it's a great way to get people interacting with these kind of stories in a new, different way. So I'm hoping that we'll get into kind of some more of the virtual gaming as well, and with VR games and stuff like that. So yeah.
Exactly. I think from what I've observed in the industry, there's going to be more sort of out of the box solutions. You're ready to just, I don't know, pull down a repository and then just get going with things like that. So yes, I would probably say the gaming industry has definitely helped. So this is one mainly for Cassandra, but I think it does actually bring in elements for what both of your projects are. Do we envisage a future of AR, VR glasses, and quantum power in our pocket?
Like, well, yeah.
Isn't it, between the two of you?
I mean, just an example, one of our partners at the University of Bristol, they're developing QKD that's basically credit card size that you'd be able to use for financial transactions, like at an ATM. So, yes.
Absolutely. What do you think of that, Bethany?
Yeah, I think that would be really great, because right now, you know, we can use augmented reality because it is in our pocket. We can pull out our phones, but if we had a way to, you know, use VR in the field in these open spaces, I think that would be brilliant. So yeah, I hope that can move forward. Yeah.
Oh, that's wonderful. Oh, well, thank you both so much. I know there's a couple more questions that have come in from socials, but hopefully later you can respond on those channels, because I must wrap up now that we're coming up to 1 o'clock. I think people will be heading to their afternoon meetings and things like that. But thank you both for attending today, and thank you to our audience for being here. We do have a lot more events coming up in the coming weeks. We've got AI for leaders, AI in ethics, and the big one is our Great AI Summit, which is in October. It's on the 12th and 13th of October, and it's actually a hybrid event this year. We've been able to adapt to these unprecedented times. There'll be things like the virtual hall, virtual networking, there's some VIP booths and everything. So if you are interested, do sign up on our website. We are actually offering early bird discount, which I think is 10%. So that's super exciting. But that is all from us today. So please do offer a virtual round of applause to our guests, Cassandra and Bethany. It's been an excellent session, and stay safe, everyone. Thank you very much. Bye.
Thank you.